我们再从头复习一点这个第5章的开头的知识然后我们再切入到比较复杂的内容。So first, we review some basic ideas in this chapter. First, we have the formulation for the so-called wave plate. When we say waveless plate, we mean that a piece of anisotropic crystal and we cut the crystal to a piece and the thickness is say D. And we choose to cut this crystal in the way that one principal axis is perpendicular to this surface， 就是有一个主轴跟这个表面是这个垂直的。So the other two principal axes are parallel to the surface of the wave plate. And one of the principal axes is named the slope axis, the other is named the fast axis, which means that the two corresponding refracting faces are larger and smaller. 就这个其中一个轴，假设你的电场对着它的话，你所得到的这个折射率是高的，这个折射率是低的。所以高的折射率走得慢，低折射率走得快，所以就叫慢速，叫快速。So if we choose the electric field of the incident light to have the electric field along this slope axis, then the corresponding refracting index is large. And if we choose the incident light to have the electric field parallel to the fast axis, the corresponding refracting index is small. And large refracting index means propagating slowly, and small refracting index means propagating faster. Okay? So we call this slow axis fast axis. Then, if we send a beam of light whose electric field is along some arbitrary direction, then we can project this electric field to the two principal axes to get the corresponding two components. We have, say, electric field along this direction, then we can project the E vector to the two axes. Then this component, penetrating through this wave plate, get a larger phase aggregation. 就是说，这个分量呢，因为 slow axis 是大折射率，所以通过这一件摸遍之后，它累积的光层差或者相位差比较大。Okay, and along this axis, since the corresponding refracting is smaller, then phase aggregation is smaller. Okay, then since these two components get two different phase aggregation, so finally when they add it together, we get a different coalition. So the coalition becomes, say, impact. And we can calculate the effect of the wave plane by just considering the projection and calculate the phase aggregation corresponding to the thickness. However, if we try to formulate the problem mathematically, then we find that the wave plane can be represented by a W0 matrix. If we work in the crystallograph, if we consider this problem in the so-called crystallograph, crystallograph means that the x-axis is the slow axis, the y-axis is the fast axis. So the mathematical representation of this wave plane in the crystallograph is the W0 matrix. However, usually we need to consider this problem in lab terms. In lab terms, since usually we set the axis and the y-axis of the lab graph different from the slow and fast axis. And there, in general, has a non-zero angle between the s-axis and the x-axis. So, if we want to represent the physical effect of this wave plane by a matrix in lab graph, then we should change it to W. The W here is R minus psi. W0 R psi. Okay. Here R is the rotation matrix. R psi is the rotation matrix. Cosine psi, psi psi, minus psi psi, cosine psi. And the rotation matrix R psi in the terminology of mathematics is called SO2 rotation. SO2 in mathematical language. In mathematics language, R psi is a matrix belong to the representation of SO2. S here means special. Special means the determinant is equal to 1. O means orthogonal. Orthogonal means this T times R is equal to unit matrix. Okay, you can check that the transpose of R is the inverse of R. Okay, and it also has this property that R psi 1 times R psi 2 is equal to R psi 1 plus psi 2. You just add the two angles together to get the total angle of the rotation. So, in addition to the wave plane, we have another thing called polarizer. A piece of thing that allows the light to penetrate through if the incident light has the polarization parallel to certain direction. We name this specific direction transmitting axis. Suppose we have an incident light whose electric field is along the transmitting axis. Then the light can penetrate through this horizon completely. Okay. However, if we have incident light whose electric field is perpendicular to the transmitting axis, then it would be absorbed by the horizon completely. 平行的这个特殊轴的时候，就完全传播；如果垂直于它，就完全吸收。啊，理想上是这样啊。实际真实状况当然是，这个所谓的完全通过也会吸收一点点的啊。然后呢，这个所谓的完全吸收，其实也不见得是完全吸收了，它其实也是会有部分的反射啊。但理想状况就是当时这个完全通过或完全吸收啊，所以这个就是所谓的 horizon。Mathematically, we can represent the physical effect of the horizon by a matrix called P. Suppose the transmitting axis is along the x-axis, then we denote the horizon as Px, and we can represent it as 1, 0, 0, 0. Okay. And if the transmitting axis is along the y-axis, then we can represent it as 0, 0, 0, 1. Here we use the convention that we denote the x polarization as 1, 0 and the y polarization as 0, 1. Okay? So you can check that when you multiply Px to the x polarization, you get x polarization, which means the x polarization line can penetrate through the horizon completely. However, if you multiply Px to y polarization, you get 0. This means that the y polarization line will be absorbed by the horizon completely. Similar result can be applied to the y horizon. You can multiply y horizon to the x polarization and get 0, and the y horizon times the y polarization to get y polarization. Okay? And using these two basic representations of for the x polarizon and y polarizon, you can find the representation for a polarizon whose transmitting axis is along certain arbitrary angle, say psi. So we can represent the horizon whose transmitting axis is along the direction psi. Then this horizon can be represented as r minus psi times px times r psi. Okay, just like what we did for the wavefront. Okay, but now these two kinds of metrics has different property because For the wave plate, we have W dagger times W equal to unit matrix. That's because if you calculate the determinant of the W matrix, you always find 1. Okay. Determinant W is equal to 1. Okay. That's because physically we treat physically an ideal wave plate can change the polarization state of the incident light, but it will not absorb or reflect any part of the incident light. Okay, so 这意思就是说，理想的 wave plate 呢，对入射的这个电磁波所做的事情，其实只是改变它的 polarization state。它既不把电场放大，也不让它缩小。OK， 就是放大就是 gain 啊，缩小就是吸收嘛，然后或者是部分的反射啊，它都不做这些事，它只改变你的 polarization， 改变的方式就是方向转来转去，或相位变来变去这样子而已啊。那这个东西在数学上描述就是 W dagger W 等于啊。那这个所代表的意思就是电场的这个强度啊，或者长度啊没有变啊。那但是 polarizer 不一样 ，polarizer 的话呢，它会把其中一部分吃掉啊，它会把不对的分量吃掉。OK， 所以这两个是不一样的。如果你去计算这个 polarizer 的这个矩阵的行列式，你会发现它等于0。这是因为你去求它的这个 eigenvalue 的时候，它 always 一个 eigenvalue 是1，另外一个是0。0那个代表完全吸收掉，1那个代表完全通过。好 ，so if the device does not absorb any part of the incident light, then mathematically this device can be represented by unitary matrix. Unitary matrix means W dagger W equals to identity matrix. And this implies that the magnitude of the electric field will not be changed by the wave plate. Okay. However, for polarizer, the situation is different. Okay. Because if you have an incident light whose polarization say we have incident light whose polarization is alpha x plus beta y. Okay. Then if you multiply px to this E vector, you get only the alpha x part. Because the y component has been absorbed by this polarizer. Okay. So this kind of matrix is not unitary matrix, but they are called projection matrix or projection operator. 好，这叫投影算符或投影矩阵啊，投影啊，因为它只有那个影子投影那部分通过，其他的部分就吸收掉啊。So if we discuss wave plate and polarizer separately, then this is a little bit boring. However, if we combine them, then we can do something more interesting. Okay. So in the practical application, we often combine both of them. Okay. So, suppose we have a wave plate gamma, whose gamma means the phase difference of the two components. Suppose the phase difference of these two projecting components of the E field, the incident E field, after penetrating through this wave plate, the phase difference, suppose the phase difference is pi, then this wave plate is called half wave retardation. Then if we choose the slow and the fast axis to be along the (45° and 175° with respect to the x-axis, and choose the incident light to be polarized along the y direction. The incident light is y polarization, along the y polarization, and the slow axis and the fast axis are chosen to be along this direction, this direction. Then you can see that what is the result, what is the effect of this wave plate on the incident light. We know that now we have gamma equals to pi. Pi means that exponential I gamma is equal to exponential I pi, which is a negative sign. Okay? So this means that the E vector incident like E vector is along the y direction. We can write this as 1 over square root 2 ES plus EF. Okay. Here ES and EF are the two unit vectors along the slow axis and fast axis. And remember that the slow axis along the direction, the orientation of the slow axis, 45 degrees with respect to the x-axis. Then, after penetration through this wave plate, the new polarization becomes this one. The S part, the S component, get a phase aggregation exponential minus I gamma 2 times ES. Okay. And the fast axis, the electric field, the wave along the having electric field along the fast axis get a phase difference, phase aggregation, phase factor exponential I gamma 2. This times EF. Okay. Then we factor out this exponential minus I gamma 2 and find this ES plus exponential I gamma EF. Okay. And remember that this factor is irrelevant. 这个 factor 不重要，因为我们在讲这个 translation 的时候，这个 total phase factor 是不重要啊。When we speak about polarization of light, the total phase factor is not important, so you can ignore this phase factor. However, you see that now originally we have ES plus EF. Now we have ES plus exponential I gamma times EF. And we see that for gamma equal to pi, exponential I pi is minus 1. So this means that we change the plus sign. Originally here is a plus sign. Now becomes a negative sign. So this means that we can think the result intuitively. We can think this problem intuitively by observing that originally we have this component and this component, both of which have the same magnitude. And then I keep the first component unaltered, but change the second component to its negative. Ah. 就本来我们分解成这两个分量，然后呢，我保持其中一个分量不变，但是另外一个分量呢，变到它的负号，变到它的负号。所以这时候本来 ，so originally we have this polarization, and after penetration through this wave plate, we get this polarization. Okay. Ah, 所以这个非常容易了解啊，非常容易了解。好 ，That's why half-wave plate can be used to change the polarization from Y polarization to X polarization. Okay. Similarly, if you send a beam of light whose polarization is X polarized, then after penetration through this half-wave plate, you get a Y polarization. Okay. 好，那但是这个东西是因为我们把这个角度设定成45度。那如果不是45度会怎样？啊 ，So now we consider a situation that if we still use a half-wave plate, but the slope axis is along a different direction. The slope axis, the angle between the slope axis and the x-axis is an arbitrary angle psi. Suppose this is the x-axis and this is the s-axis. The angle between them is psi. Then suppose initially we have x polarized light. Okay. What will be the final polarization? Okay. You see that originally this can be the original polarization, the x polarization, can be written as the vector sum of this component along the s-axis and this component opposite to the fast axis along the fast axis. Then you see that if the wave plate is a half-wave plate, we can tip this component unaltered and change the sign of the other component. So this, we change the sign of the second component to get this, and you see that this is the E prime vector. And E prime vector, the angle between the E prime vector and the x-axis is in fact 2 psi. Okay? Because this is psi, this is psi. So this is 2 psi. Okay? You can examine this result by calculation, because now we have W equal to this R minus psi means cosine psi minus psi 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 cosine psi, and minus I 0 0 I times cosine psi 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 minus psi psi cosine psi. Okay, and this is, I can factor out the I factor minus I factor. Here I can change this to 1 minus 1. I factor out the minus I. Then this becomes minus I times, I can multiply this to this one. Cosine psi minus sine psi, sine psi, cosine psi, and cosine psi, sine psi, sine psi, minus cosine psi. And what is this? W is minus I times cosine squared minus sine squared, which is cosine 2 psi. Okay? Cosine sine, sine cosine. 2 sine cosine means cosine, means sine 2 psi. Okay. Sine cosine, sine cosine. 2 sine cosine means sine 2 psi. And then finally, minus cosine 2 psi. Okay? So you see, if we multiply W to x, then we get W times 1, 0, and this is minus I cosine 2 psi sine 2 psi. This is irrelevant factor. And what is this? This is a vector making an angle 2 psi with respect to the x-axis. OK？ 所以 x 偏正就被转到2、3个角度去。OK？ 好，所以你可以用不同方式去思考，不一定要从头算到尾啊。或者是你也可以从头算到尾，但是你多一点这种直觉，比较容易帮助你判断说，你有时候不小心算错了，你就至少知道你可能错在哪里，或者及时把它改回来啊。好，那这个是关于这个 halfway plate 啊。那我们后面也学到了，就是说，如果把 halfway plate 呢，这个或者是任意的 wave plate 呢，去跟 polarizer 做结合的话，就可以变出一些花样。好，那通常的做法是这样，就是说，我们可能先通过让光先通过一个 polarizer， 然后经过一些 wave plate， 然后最后再让它通过另外一片 polarizer， 取出我们要的那个成分。好，那这时候呢，就可以去变一些花样，比如说后面我们会介绍到的滤波器啊，叫 soak filter， 还有这个 fan soak filter 啊，这个的话我们后面再讲，但我们先再复习一下，就是如果把一个 wave plate 夹在两块 polarizer 之间的话，怎么去理解它啊 ？So， 好，在这之前我们再讲一个，就是刚刚讲的都线偏正嘛，那如果我是圆偏正会怎样啊 ？So since now we know that for halfway plate we can think it as we keep one component unaltered and change the sign of the other component. So if you send a circularly polarized light into this wave plate, then what happens? Okay. Circularly polarized light means that we have this. For example, right-hand circularly polarized light minus I EF. Okay. Then you see that now this becomes this, and this gives us this. And this means that we change the right-hand circularly polarized light to left-hand circularly polarized light by using half wave plate. Okay. You can also use the so-called quarter wave plate. Quarter wave plate will not change the sign of the second component, but just give an I times I or minus I times the second component. So it can change linearly polarized light to a circularly polarized light, quarter wave plate, or vice versa. Okay, you can send the circularly polarized light into a quarter wave plate to change it into a linearly polarized light. Okay. So, if we combine polarizer with the wave plate, so we have the consideration of transmissivity. Transmissivity. So, if we have a wave plate whose retardation is gamma, then if we send a beam of unpolarized light into a polarizer, and after penetrating through the polarizer, it becomes polarized, and then it encounters a series of waveplates, and finally penetration through the second polarizer. Okay, then usually we call this polarizer. And we call the final polarizer analyzer. Analyzer is just the second polarizer. Okay, you use polarizer to prepare the initial polarization, and you use analyzer to analyze the final polarization state. In between, these are some wave plates. Okay, and yeah. So you can choose the analyzer to have the transmitting axis parallel to the polarizer or orthogonal to the polarizer. Okay, to get different results. And finally, you can calculate the transmission of the light. Now, we consider the problem of calculating the transmittance for the so-called folded filter. A folded Stoker filter is like this. And then finally, this polarizer. Analyzer. This means that we arrange a series of waveplates between these two polarizers in this way. Here, originally we have the X polarizer. Okay, and the first waveplate, we choose the slope axis to be oriented along the positive rho angle. And the second one has an orientation angle to be minus rho. And third one, the orientation to be along positive rho again. And the fourth one, minus rho. And repeat this arrangement finally we still have positive rho and minus rho, and then the analyzer is the Y polarizer. Okay. Positive rho, negative rho, positive rho, negative rho. These are the orientation angle of the slope axis. 这些正ρ负ρ代表的是慢轴的角度啊，就跟 x 轴的夹角，跟 x 轴的夹角啊，这个夹正ρ夹负ρ夹正ρ夹负ρ夹正ρ负ρ等等啊。然后呢，最后呢，让它通过一个polarizer是穿透轴是 y 的啊，入射这边是 x。那总共有 m 个周期 n 片啊 ，so this is a period, okay? A period of the structure consists of one piece along positive rho and another piece along the negative rho direction. Okay, we have totally m periods, and we denote the total number of waveplates as n. N is 2m. Okay. I will discuss the details next hour. Okay.圆偏振的问题的时候啊，我直接用了一个结果，是我把圆偏振写成这样子，根号2分之一ES 减 I EF 我说这个是右旋圆偏振那有的同学可能会觉得说，这个你用的轴不对这个我们本来是在 left frame 里面是 x 轴 y 轴那真的能这样写吗？那我这边来稍微提一下，就是圆偏振你在任何的坐标轴都写出来，都可以像这样写，差别只是前面的 phase factor 不一样。怎么看出这一点就是说，那我们以ES、EF 是 跟 x 轴 y 轴夹45度为例来看这件事啊。So I now show you that for circularly polarized light, you can write it as this. Right-hand circularly polarized light can write it as this or this. The only difference is the prefactor, the phase factor. Okay. We see that since we choose ES and EF to be along the positive and the negative 45 degree, we can write ES as this. And we can write EF as this. Okay. So this means that this means that X X can be written as square root 2 of ES minus EF. Yeah. And Y can be written as this. So originally, the right-hand circular polarization, right-hand circular polarization, we can write it as okay, and this becomes this one. However, you can see that if we factor out the factor 1 minus I, we get ES minus 1 plus I over 1 minus I, EF. Okay. And this one, this factor, can be written as this, and this is just 1 plus 2I minus 1, 1 plus 1, okay? So this is I, this is I. So we see that now we have ES minus I, EF. So you see the combination, the coefficient 1 minus I, okay, is the same as 1 minus I. The only difference is this factor. This factor is equal to this. This is just
And this is just exponential minus 1/4 pi. Okay, and this pure phase, this phase factor is irrelevant in judging the polarization state. 所以这部分可以不用管，然后呢，剩下的结构其实跟原来的是完全一样，完全一样啊。所以你可以把坐标轴转掉，但是呢，你的圆偏振仍然是同样的圆偏振，这点跟线偏振不同。线偏振你转了，它就是不同的线偏振，但是圆偏振的话，转坐标轴还是圆偏振。这道理其实还蛮简单，因为圆偏振它的行为的是转圈圈，那转圈圈其实并没有一个特定的指向，对，它就是一直转圈圈。所以你参考这个轴或参考这个轴，它都是转圈圈。好 ，So this is the feature of circularly polarized light, because for a circularly polarized light, the electric field rotates with respect to the center, and you can choose any coordinate axis to observe the same behavior of the circularly polarized light. Okay. 好，然后接下来我们应该继续来讲这个folded soak filter. So now we come back to the discussion of folded soak filter. Folded soak filter. So now we discuss a very special situation. If we choose gamma to be pi, half wave plane, suppose each piece of the wave plane is half wave plane, half wave retardation plane. Okay. Then what would be the result of this device? First, we send a beam of unpolarized light. Then after penetrating through the first polarizer, X polarizer, we get the polarization along 0. Okay, 0 means X polarized light. Okay. And after penetrating through the first wave plane, we get the orientation of the polarization to be 2 rho. We have already explained this because if the angle between the slope axis and the x-axis is rho, then after horizontally polarized light penetrates through the wave plane, the final polarization becomes along the orientation to rho. Okay. Then, so originally we have this horizontal and rho is the wave plane orientation, and the new polarization becomes 2 rho. 2 rho. And now the next wave plane has its slope axis along the negative rho. Direction. And the angle between this polarization and direction of next row is 3 rows. This means that this polarization after penetration through this waveplane will become this new orientation. Negative 4 row, the angle between negative 4 row and minus row is 3 row. Okay. So now this becomes negative 4 rows. And now negative 4 row, the next one, the next waveplane has slope axis along the positive row, and the angle between negative 4 row and the positive row is 5 row, and we add 5 row to this positive row to get positive 6 row. Okay. So you see the polarization orientation from 0 change from 0 to 2 row to negative 4 row to positive 6 row, then to negative 8 row, etc. Okay. So one period. Second, third, second period, and then we totally have m periods. Okay. So you multiply 4, negative 4. This is the nth period. Okay. So then it encounters, here we have px, then it encounters the y polarized. Okay. So if we hope if the final polarization can transmit through the y polarizer, then this means that we must have 4m row equal to half pi, because the angle between the x-axis and y-axis is half pi, or 2n row equal to half pi. Okay, because n is equal to 2n. N is equal to 2n. N is the total number of the wavelength. Then this means that rho is equal to pi over 4n. If we hope if we hope it happens, this kind of situation happens, then we must choose rho to be pi over 4n. What kind of situation? When gamma is equal to pi, we hope the wave can penetrate through the whole device and transmit through the analyzer completely. Okay. If we hope the result is this, then we should choose rho to be pi over 4 and n is the total number of the wavelength. 所以如果我们希望在伽马等于派的时候，它可以全部通过的话，那如果要选择派除以 4n，那可是伽马会不会一定等于派呢？我只要改变光的波长，伽马就跟着变，只是某个特殊的波长的时候，会刚好对到伽马等于派。If we change the wavelength or frequency of the incident light, then gamma changed. Okay. However, for some specific wavelength or frequency, we will have gamma equal to pi or odd number times pi. More. Nu is an integer. 那实际上伽马是个什么东西呢 ？In fact, what is gamma? Gamma is this 2 pi over lambda times ns minus nf times the thickness of the wavelength. L is the thickness of the wavelength. Okay, and usually we can choose, say, Ne, No to be Ns and Nf. Okay, this means that we choose Ne is larger than No, positive uniaxial crystal or something. Okay, then we have this gamma. Gamma is inversely proportional to the wavelength. This wavelength means the wavelength of the light in the vacuum. Okay. So if we change the wavelength, gamma changes. Okay. So for some specific lambda, we can get gamma equal to pi or gamma equal to odd integer times pi. Odd integer times pi. Once we have gamma is equal to odd integer times pi, then the wave plate under this assumption behave as a half wave plane, half wave retardation plane. Okay. Then if we choose rho to be equal to pi over 4n, then the light can penetrate through the whole device completely. Okay. Now we want to analyze what happens if gamma it has a value a little bit different from pi or odd integer times pi. If we want to analyze this result, we must discuss how to multiply the matrix of this wavelength. Okay. 我们必须要知道怎么去把这些矩阵乘起来。You can say that I can do this just use computer. Okay. Yes, you can do this just use computer. But sometimes you can get results directly from computer program, but you don't know why the result is that. Okay. So we need to do some analysis about this manipulation, this arrangement. 我们要探讨一下说为什么 结果会是那个样子。而且呢，有些时候我们其实不需要知道100%的准确呢，可以去大致知道这个结构的行为那就帮助我们去了解为什么去设计这样的东西那为什么它是一个 filter So once we know how to multiply the matrices of this series of matrices, then we know why the function of this device is just like that. OK， 好，那我们就来分析一下怎么去把它乘起来。So mathematically, the multiplication of this wave plates, we can denote the matrix as M. And what is M? Suppose we denote the matrix corresponding to the first wave plate as W rho. W rho is R minus rho, W0 R rho. And the matrix the second wave plate is represented by W minus rho, which is R rho W0 times R minus rho. Okay? Then in one period, we have a combination of W rho and W minus rho. W minus rho times W rho. This is the, maybe I can denote this as omega. Okay. I denote the product of W minus rho and W rho as capital omega. Then for the total n periods or n pieces of wave plate, we have the matrix M. M is equal to the nth power of omega. Okay? Because we have omega n times. Okay. So now we try to learn how to calculate these things. Let me denote this omega as A, B, C, D, A, B, C, D. Then what are these A, B, C, Ds? What is W rho? W rho is this cosine rho, sine rho, minus sine rho, cosine rho, times W0 is exponential minus half gamma. Okay, exponential half gamma times cosine rho minus sine rho sine rho cosine rho. Okay, and I try to find the expression of W rho. This time is exponential minus I half gamma cosine rho, exponential I half gamma sine rho. Minus exponential minus I half gamma sine rho, exponential I half gamma cosine rho, and this times this. And the result. Okay, the result is a little bit tedious. You can try to calculate the W rho. And how to find the W minus rho? You just replace rho by minus rho, then you get W minus rho. Then if you know how to, if you have enough patience to calculate the product of W minus rho times W rho, then you can get this A, B, C, D. Okay? I just cite this A, B, C, D here. A is this cosine half gamma minus I cosine 2 rho sine half gamma squared plus sine squared 2 rho sine squared half gamma. This is the A factor. What is B? B is in fact a negative sine 4 rho sine square half gamma. Notice that here we have a negative sign, which is different from the result listed in the textbook. This proves that I had ever tried to calculate the ABCD by myself, not just believe the results listed in the textbook. 好，这个负号说明我是真的算过的，好，只是现在是上课没有办法这样算，太花时间了。What is C? C is negative B. This is correct, which means it is positive sine 4 rho sine squared half gamma. Finally, what is D? D is in fact A star, the complex conjugate of A, which means that D is equal to cosine half gamma plus I cosine 2 rho sine half gamma squared. cos sine squared 2 rho sine squared half gamma. Okay, this is the factor D. Then with this A, B, C, D, we are ready to find the result of M. How to calculate the mth power of a matrix? You learned in your linear algebra class or engineering mathematics class that you can try to diagonalize the matrix omega. Then for a diagonal matrix, it is very easy to calculate its mth power. Then you can just use the similarity transformation to find the final result of the M. Okay. However, now we want to show you another method to calculate the mth power of omega. We can use inductive method 一个归纳法去发现它的结果to find the final result and we will find an identity called Chebyshev's identity, and then we can use the Chebyshev's identity to calculate the mth power of the matrix M. In fact, with computer, you can just calculate the mth power of the matrix directly. Okay, if you are only interested in the numerical result, you can do like this. Okay. However, it would be very how to say? It will be more insightful to consider how to calculate the mth power of a matrix. OK， 好，那总之我们现在呢要想办法来计算这个矩阵的 m 次方。好，那我们现在来试这样的方法。好 how to find the mth power of this matrix? First, we know that the determinant of omega is the determinant of W minus rho times W rho. And according to linear algebra, you know that the determinant can be factored as determinant W rho minus rho and the determinant W rho. And we have already calculated the determinant of W. We see that W is unitary matrix. It has determinant equal to 1, and this is equal to 1. So we get 1. Okay. So this is the very important result for the determinant of omega. This means that AD minus BC is equal to 1. AD minus BC is equal to 1. However, according to linear algebra, what is the determinant of the matrix? Suppose we have suppose we find the eigenvector of the omega. Say the first eigenvector is v1, we get eigenvalue lambda 1, and the second eigenvector is v2. The corresponding eigenvalue is lambda 2. Then we can collect v1 and v2 V1 and V2 to find the matrix S, then this can be written as omega times S equal to S times lambda. Here lambda is lambda 1, 0, 0, lambda 2. Okay? Then this means that omega is S lambda S inverse. So the first method to find the nth power of omega is calculating the result of this, and this is just equal to S lambda S inverse S lambda S inverse S S inverse S S inverse. So finally, this result is just equal to unit matrix, and the unit matrix times any matrix get the original matrix. So this is finally we get S nth power of lambda and S inverse, and this is equal to S times lambda 1 nth power 0, 0, lambda 2 nth power S inverse. Okay, so in this way you can calculate the nth power of some matrix. However, this way is not very convenient to use because we need to find the eigenvector V1 and V2, and so that we can find the matrix S and the inverse of S. Okay. There is a different way to find the nth power for 2 by 2 matrix, and we can use A, B, C, D and some other parameters to represent the final result of the nth power. Before doing that, let me remind you that since omega is equal to S lambda S inverse, this means that the determinant omega is determinant S lambda S inverse. Okay, and this is just equal to determinant S inverse S times determinant lambda, and the result is this is unit matrix. So the determinant of unit matrix is 1, and this. So finally, the determinant of omega is just equal to lambda 1 times lambda 2. Okay, and we know that determinant of omega is equal to 1. So this means that lambda 2 is the inverse of lambda 1. Okay, we have this property. We have this consequence that lambda 1, lambda 2 is equal to 1. This implies that lambda 1 can be written as something, say, exponential I theta, and lambda 2 can be written as exponential minus I theta. Okay, In general, theta can be complex, okay, but we will see that under some certain situation, the theta is real. Okay. 你看这两个是互为导数嘛，就是让它相乘等于1啊。那如果你有质疑说，可是浪达的绝对值不见得等于1啊，那没关系，你选的 theta 是 complex， 它的绝对值就不会是1了啊。So, in general, you can choose a complex theta so that the magnitude of lambda 1 is not equal to 1. Okay? We just parameterize lambda 1 as exponential I theta and parameterize lambda 2 as exponential minus I theta. Then, why we need to parameterize them like this? Because I need to use a property of the matrix that is this is so-called similarity transformation. For omega and the lambda, for these two matrices, they are similarity. They can be obtained through, can be changed from, transformed from one to the other by using the similarity transformation. Then we can get a property that the trace of omega is equal to the trace of lambda. Trace means the sum of the diagonal elements of the matrix 啊，就是数学上呢，你把一个矩阵的这个主对角线的分量全部加起来，这个叫做那个矩阵的 trace。那如果两个矩阵之间是互为相似变换的关系，那数学上可以证明说它们两个的 trace 是一样的。那 trace 一样代表什么意思呢？就是我们知道这个大浪的矩阵，它两个 eigenvalue 就是浪达 1 对角线是浪达 1 加浪达 2， 就是浪达 1 加浪达 2， 对不对？但是呢，这个 omega 的 trace 是什么呢？就是 a 加 b。A plus B. Okay. So this means that since now we denote lambda 1 as exponential I theta and lambda 2 as exponential minus I theta, this becomes 2 cosine theta according to Euler's relation. So this means that we define cosine theta as 1/2 of A plus B. In the textbook, you see the author define something called 课本的那个浪达跟我们的浪达是不同的浪达啊。The capital lambda in the textbook has different meaning to my capital lambda. Okay, the capital lambda in the textbook means the period, the length of the period of the periodic structure. Okay, so I just change the notation in the textbook k lambda to theta here. Okay, k lambda in textbook is the notation theta here. Okay, 我把课本的 k lambda 叫做 theta， 看到课本的做法是 cosine k lambda 等于1/2 a 加 b， 然后我是 cosine theta 等于1/2 a 加 b， 是同样的意思。好，那我现在呢？我定义这个东西能干嘛？我现在就要拿它来用了告诉你说为什么可以用它来 找出一个递回关系，好，把 m 次方矩阵的 m 次方给算出来，好 ，we can use this definition to find the mth power of the matrix capital omega. We have capital omega equal to A, B, C, D. And remember, we have this restriction, AD minus BC is equal to 1. This is the consequence of the fact that capital omega is equal to W minus rho times W rho. And since both W have the result of determinant equal to 1, then we have the determinant of omega equal to 1. And the determinant is just equal to AD minus BC. So, if I calculate omega squared, we see that the result is AB CD times AB CD, and this gives us A squared plus BC, and AB plus AD, AB plus BD, so it is B times A plus D, and CD times AC, C times A, D times C, so it's C times A plus D. And finally, we have D squared plus BC. Okay. So now we know that AD minus BC equal to 1. This means that BC can be written as AD minus 1. Okay. So this means that we can write the result as A squared plus AD minus 1. Here, D squared plus BC, D squared plus AD minus 1. Okay. B times A plus B, C times A plus D. Okay. And you see here A squared plus AD can be written as A times A plus D. So I can rewrite this as A times A plus D minus 1. And I can rewrite this as D times A plus D minus 1. Okay. And 我先把这个二次方的先写完。And the result is equal to A plus D times A, B, C, D minus unit matrix. Okay. And this is just equal to 2 capital omega cosine theta minus unit matrix. 好，我们先在这边暂停一下，好，我们就先下课。So now we see that square of capital omega is equal can be reduced to the first power of omega and the unit matrix. So we can try to calculate the cubic of omega, cube power of omega. Okay, then this is just equal to omega times 2 omega cosine theta minus unit matrix, and this is 2 omega squared cosine theta minus omega. Okay, and we can use the result to before we write the next line, I can rewrite this result as omega squared. This we can multiply and divide by sine theta. And 2 sine theta cosine theta is equal to sine 2 theta, okay, and minus this, okay. So this means that omega times omega squared, and this is equal to this omega squared sine 2 theta minus omega sine theta over sine theta. But now we can substitute the result here into this expression, omega squared, and find the result is 2 omega cosine theta minus 1 times sine 2 theta minus omega sine theta over sine theta. And this means that this is 2 sine 2 theta cosine theta minus sine theta times capital omega minus I sine 2 theta over sine theta. But what is this? But what is this combination? We can write this as and here we add this and minus this. result is this gives us sine 3 theta. And this gives us sine theta and minus sine theta. So finally we get sine 3 theta. Okay. You can also try to use Euler's exponential I theta formula to simplify this result. And the final result is also sine 3 theta. So we see that now we have this okay. So you see, for omega squared, you have omega sine 2 theta minus I sine theta in the denominator. Okay. Then for omega cubed, you have omega sine 3 theta minus I sine 2 theta over sine theta. So it is easy to guess the final result. If you are not satisfied, then you can try to use the 数学归纳法 in mathematically induction. And finally, we find the nth power of omega is equal to omega sine m theta sine m theta minus I sine m minus 1 theta over sine theta. Okay? And this means that we have this expression. A sine m theta minus sine m minus 1 theta over sine theta. D sine m theta minus sine m minus 1 theta over sine theta. And here we have B times sine m theta over sine theta. C times sine m theta over sine theta. Okay? This is the formula appeared in the textbook, the equation 5, 3-4. And this equation has a name. It is called Chebyshev identity. 这个东西叫做柴比雪夫恒等式。柴比雪夫恒等式，柴比雪夫是一个数学家然后你们可能会在跟几率有关的东西里面可能看到这个名字那这个就是一个恒等式是对2乘2矩阵很好用你可以直接这样用它。好，那我们一旦知道了这个恒等式，知道可以用这些 a b c d， 然后 a 加 d 除以2定成 cosine θ 然后呢去弄出这个 m 次方之后，好，那我们现在要具体进入到去计算这个 transmission 就是我有这个 polarizer 两边一个是这个 x 偏正，一个 y 偏正，然后中间是这 m 的 wave plate 乘好，然后再最后通过我要把 transmission 算出来那这个 transmission 最后算出来呢，它会表现出一个什么样的行为呢？这是我们等一下要去分析的那首先我们先要知道的是说，我们究竟会算出什么东西来这边的话，这个我们刚刚把这个叫做 m 矩阵We denote this m power of capital omega as m, okay? Then now we discuss what is the transmission related to the matrix M.好，那我们现在就是这样，就是说，我们打进来是 px， 出去是 py， 中间是这个 m 个这个周期每个周期有两片 wave plate 然后这个中间这个矩阵我们把它叫大 M， 然后我们现在假设入射的光是 EX EY， 那出射的我们把它叫做这个 EX prime EY prime。那我们想要知道最后的结果是什么So suppose I denote this as M11, M12, M21, and M22. Okay, and this means we have this 0001. Okay, M11, M12, M21, and M22. And this is 1000 times EX and EY. Okay, and this is equal to 0, 0, M21, M22. 这两个矩阵相乘是这样，那这两个相乘会等于什么呢？会等于EX 0. So finally we have this 0 M21 EX. Okay, so this means that finally we have EY prime equal to M21 times EX, and EX prime is equal to 0. Okay, so what is the transmission, transmittance? This 这个书把 transmittance 叫 transmissivity transmissivity 这三个字都同样的意思Transmissivity, T is the absolute square of the ratio between EY prime and EX, okay, and which is just the absolute value square of M21, okay. And we know that now M21 is this C times sine M theta over sine theta. Okay. And what is C? C is negative B. So this is equal to sine 4 rho sine square half gamma times sine and theta over sine theta squared. Okay, so we can use this formula to calculate the transmissivity. Remember that in the beginning, I have already explained that if the retardation for one piece of wave plate is gamma equal to pi, which means that if the wave plate is half wave plate, then the light can be transmitted totally, completely, which means the transmissivity should be equal to 1. Now let me check this result. Okay. If gamma is equal to pi, then how to find these quantities? We see that half gamma, sine half gamma is sine half pi, which is equal to 1. This is equal to 1. Okay, and we need to see 等一下，我看一下。好，我们现在要去看这个 A 和 D 现在是什么东西。我们在做这件事之前，我们先把 cosine theta 先算出来啊。So what is cosine theta? So first, what is cosine theta? Cosine theta is 1/2 A plus D. And since D is the complex conjugate of A, so this is nothing but the real part of A. Then according to the formula listed in the textbook A, you can easily find the real part of A. The real part of A is equal to cosine square half gamma minus cosine square 2 rho sine square half gamma plus sine square 2 rho sine square half gamma. Okay. 好，然后你可以用这边呢去算出这个cosine theta 来啊，你可以从这边看出一点啊，你会发现这个是 real value 啊 ，real value. So you see that cosine theta is a real value quantity. OK， 但是呢，theta 本身会不会是 real value 呢？这决定于一件事，就是这一坨东西的绝对值是落在0、1之间，还是在1以外。如果它在0、1之间，代表这个等号右边落在正负1之间，那正负1之间你就一定可以找到一个实数的 theta。但是万一这一坨东西，万一它跑到正负1以外的时候，你就没有办法找到一个实数的 theta 使得 cosine theta 等于它，所以一定要等于它的话，那你就会发现 theta 就变成 convex。OK， 好。According to this expression, if the right hand side, this part, if this part is within the range between -1 and +1, then you can always find the real theta whose cosine is equal to the right hand side. Okay. However, if it is not the case, if this expression takes value beyond the range between -1 and +1, which means it is larger than +1 or smaller than the -1, then you cannot find a real theta to be equal to this part. So you must you have to take a complex theta to get this equality. Okay, that means that this formula a similar formula can also be applied to the one-dimensional photonic crystal. Okay, in that case, this theta is equal to the period times the so-called Bloch wave number or Bloch wave vector. Okay, then if the theta is real, it corresponds to the band structure. Okay, if theta take the complex value, it indicates a forbidden band or so-called band gap. Okay. Band gap or forbidden band means the K becomes complex, which means the wave decays exponentially inside the frequency range. Okay. 好，那我们现在看一下这个东西呢，现在究竟可以给我们什么东西？我们再仔细看一下啊。So now this becomes cosine square f gamma minus sine square half gamma times cosine square 2 rho minus sine square 2 rho. Okay, and我把这个 sin 呢，抱歉，我把这个 sin 呢变成 cosine 啊。I can write this as this, and这边要去凑一个 sin， 对 ，OK， 好，没错，好。Sin square plus cosine square give us 1, okay, and then we have minus 2 cosine square 2 rho times sine square half gamma. Okay, so you see that now cosine theta is equal to 1 minus 2 cosine square 2 rho sine square half gamma. Okay. Here we see that since since now rho corresponds to a real angle we encountered in manipulating the wave plate orientation. So this cosine square takes value between 0 and 1. And gamma is also a real physical quantity. So this also takes value between 0 and 1. So the multiplication of them give us a value takes between 0 and 1. And so the final result indeed takes value between -1 and +1. So this means that now this tip is always real angle, okay, a real angle. 所以这个情况跟那个光子晶体就会未来我们假设用在光子晶体上，好，假设有机会教第6章用在光子晶体上，好，就会遇到我刚刚说的theta 变成 complex 的情况。好 ，if I have a chance to teach chapter 6, then we will encounter the situation that theta takes complex value in some situations. Okay, and now is it more convenient to change it into another expression?好，我们先看一个情况啊，就是说我们刚刚不是停在这里嘛，啊，停在这里，我们先讨论这个特殊状况。好 ，Let's discuss this special situation first. We consider the situation that gamma is equal to pi, half wave plate, and rho. Remember that rho now is我们还是需要先转换之后比较好讨论。We need to change variables so it will become more easy to discuss the result. The transformation is this. We change our variable from theta to chi. Okay. We assume theta to be pi minus 2 chi. Pi minus 2 chi. If we substitute this expression into cosine theta, we get cosine theta minus 2 chi. Cosine pi minus 2 chi. Okay. Pi gives us a minus sign, and minus cosine 2 chi is minus cosine 2 chi. Okay, because cosine is an even function. Okay, and we know that double angle. Here we have double angle formula. Cosine 2 chi is equal to 2 cosine square chi minus 1. So this minus sign changes into this expression. 1 minus 2 cosine square chi. Okay. Then if you compare this with this, you see that you can identify cosine chi as positive or negative cosine 2 rho times sine half gamma. Okay. You see that after this transformation, you can change the variable, the parameter theta to chi, so you get this simple relation. Cosine 2 chi is equal to positive or negative cosine 2 rho times sine half gamma. Then now this expression can be written as here. what is sine 2 rho? Sine 2 rho is 2 sine 4 rho, 2 sine 2 rho cosine 2 rho times sine square half gamma. Okay, and sine theta. What is sine theta? Sine theta is sine pi minus 2 chi, which is sine 2 chi and is equal to 2 sine chi cosine chi. Okay. And what is sine m theta? Sine m theta. Sine m theta is sine m pi minus 2m chi. Okay, and this becomes minus m chi. Okay, and the plus or minus sign inside this absolute value notation can be ignored. Okay, so here we have 2 sine chi cosine chi, and here we sine 2m chi, and 2m is equal to n, so we can write this as n. Okay, then we see that now here we have sine square half gamma, and we know that cosine 2 rho times sine half gamma is equal to cosine chi. So we can use 1 sine half gamma to get cosine chi times sine half gamma. Okay. And now this cosine chi can cancel with this cosine chi. And this 2 can cancel with this 2. And we can write this sine 2 rho as tangent 2 rho times cosine 2 rho. Okay, then times sine half gamma sine n chi over sine chi absolute square. And now cosine 2 rho sine half gamma is equal to cosine chi. So here this is cosine chi. Okay. This is the formula in the textbook 5.3-12. Here we just use this relation. Cosine chi is positive or negative sine half gamma. When you compare this with the result in textbook, this is formula 5.3-13. I keep the possibility of positive, negative. OK， 这边我保留这个正负号啊，课本没有这个正负号，我保留的是正负号，因为有时候需要用到。好，那现在呢，我变成这个表达式之后呢，我们来看一下，就是说，在伽马等于派的特殊情况，是否会得到 t 等于 1 啊 ？Now we discuss if for gamma equal to pi, we will get transmissivity equal to 1. Okay. So now we have T. T now is written as, in fact, sine over cosine is tangent. So this is in fact tangent to rho over tangent chi times sine n chi over sine chi. Yes. Okay. Then you see that if gamma is equal to pi, if gamma is equal to pi or to nu plus 1 pi, nu belongs to some integer. 自然数好了啊。或零啊。Then you see that when gamma is equal to pi, we have cosine chi is equal to positive or negative cosine 2 rho。意思就是说，我们其实可以直接把这个正负号忽略掉，就说 cosine chi 就是 cosine 2 rho， 或者是你就把 chi 就当成是 2 rho 了。So you can treat chi as 2 rho. Once chi is equal to 2 rho, you see that tangent 2 chi over tangent 2 rho over tangent chi is equal to 1, and this becomes sine 2 rho sine 2 n rho square. However, we see that 等一下，那个我等一下，没有这个了，没有这个 ，sorry， no this part, only this. Okay. So if rho is taken to be pi over 4n, then 2n rho is equal to half pi. Then you see that sine half pi is 1. Okay, so you see that when gamma is equal to pi, we get transmissivity equal to 1. 就跟刚刚一样，就是说，假如我们真的选择伽马是派或是奇数倍的派的话，那的确就会得到穿透系数、穿透率是1。这个跟刚刚的这个初步讨论的结论是一样。那我们现在要更进一步、更细致的去分析它，就是说，假设我的伽马不是刚好等于奇数倍的派或派，而是差一点点。我们想要知道在那个附近的话，它的表现会是怎么样？So now we want to consider discuss the situation that gamma is not exactly equal to pi, but equal to pi plus delta gamma. The delta gamma is not big enough. Delta gamma is a small variation of this gamma. Then what would be the shape of this transmissivity curve? 你想要知道那个穿透率的这个曲线会长成什么样子？如果让伽马偏离奇数倍的派一点点。Remember that gamma is equal to 2 pi over lambda times ne minus no times d. D is the thickness of the wave plate. You can use L or D to denote the thickness of the wave plate. So suppose we have gamma nu equal to 2 nu plus 1 pi. Here nu is an integer. Then the corresponding wavelength, we denote the corresponding wavelength of lambda nu. Lambda nu. Okay. Then now we consider gamma to be gamma nu plus delta gamma. Delta gamma is a small quantity. Okay. And if delta gamma is really small enough, then we have this relation, delta gamma. Suppose, assume that lambda minus lambda nu is much smaller than lambda nu. Okay, then delta gamma can be written as this: d gamma over d lambda times delta lambda. Okay, and since gamma is inversely proportional to lambda, this differentiation gives you a minus sign. So we have minus 2 pi over lambda nu squared times n e minus n o times d times delta lambda. And this can be written as minus 1 over lambda nu times gamma nu times delta lambda. And what is gamma nu? Gamma nu is 2 nu plus 1 pi. So this is minus 2 nu plus 1 pi over lambda nu times delta lambda. And the delta lambda is nothing but lambda minus lambda nu. OK， 好，所以 delta gamma 可以表达成这样啊，就是你原来的这个 gamma 呢，取那个特殊值的时候，就是某个基数乘上派，然后你这边保留那个基数乘上派，除以那个特定的频率乘负号，然后乘上这个波长的差啊，就是代表这个 delta gamma。好，那我们想看看 delta gamma 很小的时候啊，这个 transmissivity 的曲线大致上会长成什么样子？我们知道最高点是在1啦，啊，但是偏离它一点会变成什么？ To know the result, we need to analyze this relation. Cosine chi is equal to positive, negative. We see this transformation. Cosine 2 rho times sine half gamma. Okay. Now gamma is equal to this. Sine half gamma is sine nu plus 1 half pi plus half delta gamma. Okay, and we know that 这个就是基本上加上负1的纽次方这加 nu pi 的时候就变出负1的纽次方，对吧？然后 sin 的2/π加2/γ，其实就变出 cosine 2/delta gamma。So this becomes this expression, okay? So substitute this into this expression, we get positive 1, negative cosine 2 rho times cosine half delta gamma. Okay. We assume that this positive negative sign compensates with this exponential mu power of -1. So we assume this equal to 1. Okay. So we get this cosine chi equal to cosine 2 rho times cosine half delta gamma. And now we see that cosine 2 rho, cosine half, 2 rho, half gamma, delta gamma, and chi are all small quantities. For small quantity, we can try to expand the cosine function in the Taylor series form, okay, and keep up only to the square term. We keep it up only to the square term because these quantities are very small. So cosine chi can be approximated as 1 minus 1/2 chi squared. And cosine 2 rho can be approximated by 1 minus half 2 rho squared. And cosine half delta gamma can be approximated as 1 minus half delta gamma squared. Okay. So now we have 1 minus 1/2 chi squared equal to the multiplication of this and this. And we ignore the fourth power term, and we find this is equal to 1 minus 1/2 2 rho squared plus half delta gamma squared. Okay, so this means that now chi can be written as square root of 2 rho squared plus half delta gamma squared. And this is 2 rho times 1 plus 4 rho delta gamma squared. And 2 rho is pi over 2n. And this is 4 rho is这边不是 4 rho 啦，这边是等一下啊，4 rows 对，4 rows n，4 rows n 没错，好，所以就得到这个结果。好 ，so we see that now chi can be represented by pi over 2n times this. So finally, when we substitute all this result into this expression, when rho and chi are small, we can approximate tangent 2 rho as 2 rho, and the tangent chi as chi. Okay, and this finally gives us t equal to this sine half pi square root 1 plus n delta gamma over pi square over this n delta gamma over pi square this square. Okay, then you can plot this to see this shape. Looks like a sinc function, although it is not exactly equal to a sinc function, but it's something like a sinc function. 好，你们这边先消化一下，我们下礼拜再继续把这个处理完。下礼拜应该会发考卷。